Hey, ladies and gentlemen, we are starting chapter 7. 7.1 will be today's lesson. It's a wonderful lesson about monomials. You can see our first vocabulary word actually is a monomial. So this is important that we understand what these words mean so that we can understand why we do what we do for the rest of this chapter. So a monomial is a number, a variable, or the product of a number and one or more variables with non-negative integers as exponents. So this is important. It may only have one term. That's where the mono comes from. So one term. So if we look at the next four numbers here, this is something that we're going to ask you to think on your own. If you want to pause before I answer them, that's fine. But for something to be a monomial, it falls into our definition above. This first one, A, there's two terms, therefore it is not a monomial. Letter B, it is a product of a number and variables, and the exponents are positive, so this is a monomial. C, we just divided. 3 divided by 8 is 0.375, which is just one number, a monomial. And then letter D, 5 divided by W, we cannot have a variable in the denominator, therefore this one is not a monomial. All right, here we move. Hopefully we can remember these ideas from previous years, but the idea here is that x to the 5th power times x to the 8th power, all we have to do is add the exponents together. Because if you were to rewrite this, this would be 5x's, this would be 8x's, and when you multiply them all together, there's a total of 13x's. That's why it's x to the 13th power. Now, they have to have the same base in order for you to just be able to add the powers together. So a numerical example would be like 18 to the 7th times 18 to the 4th. The base is both an 18, so then we can add the exponents to get 18 to the 11th. So again, this is like having 7 18s times 4 18s, because it's 18 times 18 times 18 times 18 makes that 18 to the 4th. All right, so let's get on to a real example that you might see from your textbook. If I have r to the 4th times a negative 12r to the 7th, it's very similar to when we talked about combining like terms. My r to the 4th and my r to the 7th are going to kind of go together. So I'm going to be stuck with, because this is just 1r to the 4th, it's be a 1 times a negative 12, which still is a negative 12. And then an r to the 4th times an r to the 7th makes an r to the 11th, because we will add the exponents when we multiply. So then my official answer is a negative 12r to the 11th. Kind of similar to us with the combining like terms, but also similar to like distributing, because we're looking at the r going with the other r. All right, let's try another example. Example number 2. Again, what we just talked about, we're going to put together the things that go together. So the coefficients, 6 times 5 makes a 30. We'll put together our c's. So I have 1c times another 5c's, which is a c to the 6th power, because 1 plus 5 is 6. And then we'll have over here, we have 5d's and 2d's, so that's a d to the 7th. So that would be our official simplified answer when we multiply them together. All right, next big idea here, folks, is a power of a power. So if I have xy to the 5th, that means that this exponent gets to both things inside. This is kind of like the distributive property again. So this would result in x to the 5th, y to the 5th. On this other example, if I have a negative 3, so there's a number in the coefficient, that also gets to the 4th power. So this 4th power goes to the coefficient, and then both of our variable letters. So this would be a negative 3 to the 4th, and x to the 3rd times an x to the 4th, which multiplies them. And then we have a y to the 1st being to the 4th. So we're going to multiply. So if I had a x to the 2nd to the 3rd, this would turn into an x to the 6th, because I have 3 x to the 2nds. So that's why we can multiply these two to make an x to the sixth. All right, so an example. We're going to work our way outside or inside out. 2 to the third power turns into 2 to the third power times the second power, which gets us 2 to the sixth, and that's still going to the third, so this becomes 2 to the 18th. Now we would be able to simplify 2 to the 18th. You can take your calculator and then you can figure out exactly what 2 to the 18th power is, and it's a very large number. 262,144. Again, this is 262,144 when we simplify. Now again, we're having exponents to exponents. That's why we get to a very large number. And I'm okay if you leave it as a 2 to the 18th as well. Both of those things work for me. All right, let's try another one. Oh, that's already the one we just did. Moving on to our geometry. If I were to be talking about a cube, remember a cube means that we have a three-dimensional square. So that's one of these shapes. I'm not very good at drawing, so don't judge me. If one of the sides is a 5xyz, and we're trying to find the volume. Remember, volume is length times width times height. Length times width times height. So we're going to multiply this by itself, I guess, 3 times. So one way we could write this would be a 5xyz to the third power, because there's going to be 3 of them that we multiply. Or you could do it times itself 3 times. So the idea here is that this 3, the exponent of 3 gets to the 5. So it's 5 to the third power, which is 125. An x to the third power, a y to the third power, and a z to the third power. So we distributed the exponent to all parts of our monomial. All right, folks, we have one last example. I'm going to have you try this one on your own, and let's see if you can get it correct when you come back to class tomorrow. I wish you the best of luck. Remember all of the rules that we just talked about. I think we got this, folks. Good luck. Burma Nation, signing off.